In this video, we want to cover backhaul communications, which are the network paths that connect remote SCADA sites to a central control center. Pipelines, substations, pump stations, lift stations, and water treatment facilities are almost never co-located with the control room that monitors them. The communication medium that bridges that geographic distance determines your latency, your reliability, cost, and security exposure. The choice matters for both operations and security. Operators at a central control center need real-time visibility across dozens or hundreds of remote sites. RTUs and PLCs at those sites must send back data to the SCADA master and receive commands from it. Alarm conditions, set point changes, valve commands. The quality of that communication path directly affects the quality of control. A path with high or unpredictable latency means the SCADA master receives stale data and commands arrive late at the remote device. For tight control loops, that latency can cause operational problems. For monitoring applications where a few seconds of delay is acceptable, it matters less. A path with poor reliability means periods of lost communication during which the SCADA master has no visibility into the remote site. The remote site continues operating on its local control logic, but the central operator is blind. How the remote RTU behaves during communication loss, whether it holds last known set points, fails to a safe state, or raises an alarm, is a configuration question that should be answered before the communication path fails in a real incident. A path with poor security is an entry point. A remote RTU connected to a SCADA master over an unencrypted communication path is accessible to anyone who can intercept that traffic. The remote site, often a small enclosure with an RTU, a radio or cellular modem, and limited physical security, is a potential attack surface into the broader OT network. For utilities, pipelines, and transmission operators that own rights of way along their infrastructure corridors, private communication infrastructure is common. Licensed microwave links are point-to-point radio links operating in licensed frequency bands. They provide predictable, low-latency connectivity along transmission corridors, pipeline right-of-ways, power transmission lines, and water main corridors. Because microwave is a private point-to-point link between specific towers, it doesn't traverse any public network. The attack surface is limited to physical access to the towers and equipment on both ends, and interception of the microwave signal itself, which is much harder than intercepting internet traffic. Fiber, wide area network, and leased line connections offer the highest reliability and throughput. A dedicated fiber path between two sites provides consistent latency, high bandwidth, and physical isolation from public network infrastructure. Where fiber exists and the cost is justified is probably the preferred option. The downsides of private infrastructure are cost and geography. Building and maintaining microwave towers or fiber conduit along a right-of-way is expensive. The infrastructure can only go where it's physically practical to build it. For remote sites where private infrastructure isn't practical, geographically isolated pump stations, distributed pipeline valve sites, weather monitoring stations, public communication infrastructure fills the gap. Cellular, LTE, and 5G connectivity is cost-effective, widely available, and increasingly reliable. It's the default choice for remote RTU connectivity in most new deployments where private infrastructure doesn't exist. The critical security requirement is any cellular path must terminate at the central SCADA site through a VPN tunnel. Cellular traffic crosses a public mobile network. Without encryption, the control data and any credentials are exposed in transit, and the cellular path provides a network entry point into the RTU. With a properly configured VPN, the communication is encrypted end-to-end, and the cellular network sees only encrypted tunnel traffic. A few considerations specific to cellular. The reliability of cellular coverage varies significantly by location. Coverage maps don't always reflect real-world signal quality at remote sites. Testing actual connectivity at the site before relying on it for SCADA communication is essential. Also, whoever holds the account that controls the SIM cards controls that remote access path. SIM card provisioning should be managed by the operations organization, not left with a contractor who installed the equipment. Satellite connectivity covers locations where cell doesn't reach. Geostationary satellite has round-trip latency of approximately 600 milliseconds. The signal travels 22,000 miles up to the satellite and 22,000 miles back. For monitoring applications where reading a sensor every few seconds is acceptable, geostationary satellite works. For control applications where command response timing matters, 600 milliseconds of latency is usually prohibitive. Low Earth orbit or LEO satellites, Starlink being the most prominent example, dramatically reduces latency to 20 to 60 milliseconds. This makes LEO satellite viable for a much wider range of SCADA applications and is increasingly used at remote sites where cell coverage is inadequate. The same VPN tunnel requirement applies. Remote SCADA sites share the same security requirements as the central facility, but enforcement is harder because physical access controls are usually less robust and IT support is often remote. Every communication path into a remote site should be encrypted. VPN is the standard approach. No unencrypted communication path should connect a remote RTU or PLC to the SCADA master or to any external network. Remote site equipment should be treated as part of the OT security perimeter. If an attacker compromises a remote RTU by exploiting a vulnerability in its firmware, by gaining physical access to the enclosure, or by compromising the communication path, they may be able to use that RTU as a foothold to reach the central SCADA systems it communicates with. So segmenting remote site communication through firewalls at the central site limits what a compromised remote device can reach. VPN credentials and authentication for remote site connections should be unique per site and managed centrally. A single shared VPN credential used by all remote sites means that compromising one site's credential compromises all of them. This wraps up Module 4. In Module 5, we cover firewalls in depth, how to read rule sets, how default deny works in practice, and the most common misconfigurations that undermine even well-designed segmented networks. We'll see you in the next module.